action, there is always equal and opposite reaction. Fine. Now let me explain the same to you all properly. Okay, what it means. Yes. See, the first law of motion, Newton's first law of motion, it defines force. Okay, the second law, that also defines force, but the first law, but the first law of motion, it defines force qualitatively. It defines force qualitatively, whereas the second law, the Newton's second law of motion, student, it defines force, it gives or it defines force quantitatively. It gives the quantitative. You all understand quality and quantity, the difference. See, qualitatively, when I say Newton's first law, it tells that if a body is moving, it will continue moving until an force, external force is applied. So that is quality we are talking about. But when I talk about Newton's second law, we know that mathematically Newton's second law says F equals to ma. So here I can measure the quantity of the force also. Okay, we are relating the force with two measurable quantities, acceleration and mass. That's why we say that Newton's second law is also termed as the law that defines force quantitatively. This is very, very important, because in your exams we will not ask you directly define Newton's first law of motion, define Newton's second law of motion. Rather, we might give you like this: state and name the force which defines force quantitatively. So when it comes to quantity, it means the value. So that is obviously by Newton's second law of motion it is given. Okay, and when I'm saying qualitatively, it is the Newton's first law. Fine. Third law we can understand once I have switched to that topic. Let's see the next question, what it says. It says, how does Newton's second law of motion differ from first law? You all know, just now I've explained you this question. Okay, one is qualitatively. Newton's first law defines force qualitatively, and second law defines force quantitatively. This is very, very important. It simply defines force like this, whereas the second force exactly tells us the value, quantity of the value of force using two measurable quantities. What are the two measurable quantities? Acceleration and mass. Fine, student, this is an important question. That's why I am insisting on it more and more. Let's move to the next. Write the mathematical form of Newton's second law. This is what I was discussing again with you all. It is F equals to ma. Force equals to mass into acceleration. State the conditions, if any. Is there any condition that is needed? Yes, that I have already written here. The velocity of a body is very, very smaller than the velocity of light, which is c. This is v. Okay, when the mass remains constant. Next question. State Newton's second law of motion. Just now we discussed, so we will not go into it once again. Okay, condition we have done. How can Newton's first law of motion? Important question again. How can Newton's first law of motion be obtained from second law of motion? Now that we have understood the meaning of the two laws, Newton's first law says that if there is no force being applied, the body will not move. Am I right, student? If a body is at rest, it will remain at rest until unless force is applied. Let's substitute the same in Newton's second law. Newton's second law says F equals to ma. If I am saying no force is applied, that means force equals to 0. And if force is 0, the acceleration then becomes 0. This means that if no force is applied on the body, its acceleration will be 0. If the body is at rest, it will remain at rest. If it is moving, it will remain moving with the same speed. Thus, a body not acted upon by external force does not change its state of rest or of motion. That is what the Newton's first law says. So, this is all about this answer. Fine. Let's move to the next question. Again important, graphical representation. This I have not taken, but it is there in the pack exercise. It is there, graphical part is there, graphical representation. It is there in your book also, so I am discussing. Draw graphs to show the dependence of acceleration on force. One is between acceleration and force. What's the condition they are giving? Constant mass. So one graph is between acceleration and force when mass is constant, and second graph is between force and mass when acceleration is constant. Student, it will always be, when we write the formula, just now above we have discussed F equals to ma. See students here, F equals to ma is the formula. F equals to ma means F is directly proportional to mass, F is directly proportional to A acceleration. So when I draw graph between any two quantities that are directly proportional, when I draw a graph between any two quantities that are directly proportional, then the graph will always be a straight line. If you remember, for Ohm's law, I discussed this thing with you. For the one which obey the Ohm's law, I told you, they will have a graph as straight line. The one which do not obey Ohm's law, the graph will be a curve. So it is force is directly proportional to acceleration. It's a straight line. Okay. Let's see the next one. Again, force and mass. Again, they are directly proportional. So the graph is straight line. Remember, in physics, one concept is there which is applicable everywhere. If two quantities are directly proportional, any two physical quantities, measurable quantities are directly proportional, then the graph between the two will always be a straight line like this. Fine. Let's move to the next student. Question number 13. It says, how does the acceleration produced by a given force depend on mass of body? Draw a graph showing it. This graph is also there in your book, student. Now, acceleration and mass. If I talk about force, F is directly proportional to acceleration. If I talk about mass, F is directly proportional to mass. But acceleration and mass, they are inversely proportional. So any curve, if you draw, that represents the relationship between acceleration and mass. So any kind of curve, if you draw, that represents the relationship between acceleration and mass because they are inversely proportional to each other. I am repeating once again, acceleration is inversely proportional to mass if force is constant. Up till here, any doubt, students? Anyone? Anyone having any doubt up till here, students? Nikhil, you have understood?
No, ma'am.
Nikhil understood?
No, ma'am.
Palak?
Yes, ma'am.
Palak understood, bete? Shashi is there? Shashi,
Yes,
beta?
ma'am.
Shashi is there? Shashi?
Yes, ma'am.
Understood, bete? So your work is all complete, Shashi, so far?
Yes, ma'am.
Fine, better. Then question answers I have already shared with your class teacher today. She will be sharing it with you. You all can complete the question answers for the same. Okay. Let's continue further. Next is SI unit of force. What's the SI unit of force? It's Newton. And how do we define 1 Newton? It is the force which acts on a body of mass 1 kg and produces an acceleration of 1 meter per second square. See student, this is nothing new. This is the formula F equals to ma only. F force is equal to mass into acceleration. Force SI unit is Newton, so 1 Newton. Mass SI unit is kg, so 1 kg, and acceleration meter per second square. So 1 Newton is equal to 1 kg into 1 meter per second square. So the force acting on a body is said to be 1 Newton when the force acting is on a body of mass 1 kg produces an acceleration of 1 meter per second square. Let's see the next. What is the CGS unit of force? How is it defined? CGS unit of force is dyne, students. CGS unit of force is dyne, and that of mass is, mass SI unit is gram, and then acceleration centimeter per second square. So how will it change? Yes, please. It will change to 1 dyne equals to 1 gram into 1 centimeter per second square. See the same I have written here, it is that 1 dyne equals to 1 gram into 1 centimeter. Either you write per second square, that slash you can put, or you can write -2. But both will not be written together. Okay. 1 dyne is the force which acts on a body of mass 1 gram and produces an acceleration of 1 centimeter per second square. Now all the three questions I am telling you, student, are important. Question number 14. You can check the question number from your book. That is the SI unit. Then the CGS unit question. This is important, its definition. And the relationship. Again, 2 marks question. It was there in the board. Very, very important. SI and CGS unit of force relationship. So what's the relationship? 1 Newton is 10 raised to power 5 dyne. How do we derive it? That is also important part. So you must do the same, students. Is that clear? Yes?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Fine, beta. Let's move to the next
Yes,
question.
ma'am.
Good. Let's move to the next question. Now this is an important point. If you can write it somewhere, now I'm speaking a line, then it will be good for you. Can you all write one thing that I'll speak? Just a single line. Can you all write?
Yes, ma'am.
Okay. Okay, so just note down. I am telling you that for Newton's second, don't write right now, I'll tell you. For Newton's second law, all the reasoning that are there in your book. There are so many. Fielder catches the ball, glass vessel falls on a hard floor. Okay, many more are there. So for all these, there is one answer that you need to write. Okay, that line I'm telling you, just that one line answer is more than enough rather than writing more big explanations. So write that. Can I start, students?
Yes, ma'am.
Okay.
Yes.
Write down, bete. More is the time of impact. More is the time of impact. It's not on screen, so don't see. I am repeating it. I am speaking it. So write down. More is the time of impact. More is the time of impact. Lesser is the. More is the time of impact. Lesser is the impact of force. More is the time of impact. Lesser is the impact of force. All have written, my dear students?
Yes, ma'am.
Now understand, let's understand the meaning. Take this example only, this question only. Why does a glass vessel break when it falls on a hard floor, but it does not break when it falls on a carpet? This we see in our daily life, but let's understand physics according to that what we can answer. See, I've just now told you a line, let's relate that line with it. See, when a glass vessel falls on a hard floor, what happens is the time of impact means the time in which the body comes in contact with the hard floor surface is lesser. So the impact of force will be more. Impact of force means which causes the glass to break. At the same time, when it falls on a carpet, let's take the next part. When it falls on a carpet, what happens? The time of impact increases. The time, if it is a spongy surface, if it is the surface like soil is there or carpet is there, then in that case, the time of impact in which the body comes in contact with the surface, that increases, due to which the impact of force, if the time of impact increases, then in that case the impact of force will of course decrease, which causes or which saves the glass, due to which it does not break. So that explanation, as I said, is more than enough, student. You just have to write only that much, that if a glass vessel falls on a hard floor, in this case the time of impact is less, so impact of force is more, which causes it to break. When it falls on a carpet, in this case the time of impact is more, it takes more time, so that is why the impact of force decreases, and if impact of force decreases, it prevents the glass vessel from breaking. Fine. So this is what it was. For all the explanations you can write the same. Okay, you must have heard that a karate player, students, that he is able to break the bricks, big bricks when are placed one over the other, or ice cubes, within a single hit they are able to break it. But if we'll do that, we'll hurt ourselves. You all have heard that?
Yes, ma'am.
Karate player, they are easily able to
Yes,
break that
ma'am.
glass. They are easily able to break that glass with a very small amount of force, and they don't even get hurt. Whereas if we will do the same, we will hurt ourselves badly, whether it's breaking the bricks or the breaking of the ice cubes. The reason is there. It is again physics which is the responsible, student. What happens is they do it technically, keeping this particular concept in mind, that they decrease this time of impact. Lesser is the time of impact, more is the impact of force, which causes the ice cubes or the bricks to break. But when we do so, we don't practice the same, so we are going to take a longer time duration, due to which the force exerted, we are going to take a larger time, due to which the force acting will not be sufficient enough to break the glass or the bricks. Fine. So that can also be asked to you. So that's why I discussed. Next, see question number 18. Use Newton's second law of motion to explain the following cases. You pull your hands back while catching a fast moving cricket ball. Again, the same reasoning you can give. You prefer to land. पेपर पे लिखा हुआ ये पेपर पे लिखा. Yes, students, stop talking. Stop talking, students. Yes, please. Still, we have time for the class. Why you have started talking? Okay, so you pull your hands back while catching a fast moving cricket ball. Again, when you are pulling your hands back, you are increasing the time span. Impact of the time of impact you are increasing. So due to which the impact of force will be less, and you will save your hands from getting hurt. Okay, you prefer to land on sand instead of a hard floor while taking a high jump. Yes, this is also a good question. You prefer to land on sand. Obviously, when you land on hard floor, what will happen? Your body will instantly come in contact with the hard floor. That means the time of impact will be lesser. So, of course, you are going to hurt yourself badly because the impact of force in this case will be more. But when we land on sand, in this case, what will happen? The time of impact, more time duration you will take to come in contact with the surface. So, when the time duration will increase, of course, the impact of force will be lesser, and hence you can save yourself from getting hurt. So the same reasoning what I have told you, you can give, and this is the explanation part of what I am talking about. Fine, students, all of you have understood up till here?
Yes, ma'am.
Yes, ma'am.
Okay, so this is what actually,
Yes, ma'am.
this is what I have actually shared
Yes,
with your
ma'am.
teacher today. Class teacher, I have already sent this thing. Fine, I have already sent this thing to her. So you have to complete the same, student. Let's wait for a few more minutes and then we will just wind up the class. Okay, I'll be taking the next part, students, here. Fine, that is the